This is MATHguide.com. My name is Mark Karadimos. We're going to take a look at the Pythagorean Theorem. This is our second video on this. Our last video we calculated the hypotenuse when we're given two legs. Well, today what we're going to do is try working with a hypotenuse and a leg to calculate the other leg. Alright, so that's what we're going to do today. We're going to grab a right triangle. That's a triangle that's got a right angle in it. We're going to use this Pythagorean relationship, which is just relationship with the sides of a right triangle. Turns out that C is always the variable that's used for the hypotenuse, which is the longest side. It's the side that's opposite the right angle. So in other words, C goes here, and then it doesn't matter where you put A and B, but A and B are going to be the legs of this right triangle. Alright, now keeping that in mind, let's say we have a triangle, and let's say we have a triangle that has the one hypotenuse. Oh, there's only one hypotenuse, but the hypotenuse is 12, and let's say we know a leg is 8. Alright, what we're going to try to do is find the missing side, and this turns out that it's not the hypotenuse, so it's a leg. So I'm going to call this A. I'm going to call this B. The 8 is actually B. And then this hypotenuse is always called C. Alright, so the first thing we do when we try to calculate the length of a leg is, of course, write down the formula. Or in this case, it's an equation. It's an equation. If we're going to use it, we write it down. Now we're going to substitute in the values. Well, we don't know what A is. We know B is 8, so we're going to square the 8. And we know the C is 12, so we're going to square that. Alright, so order of operations says that we're going to square before we add. So 8 squared, 8 times 8 is 64. 12 squared, 12 times 12 is 144. Alright, so far so good. Now what makes this problem different than the hypotenuse, like solving for a hypotenuse, is that here we are solving for a leg, and we're going to have to get rid of this. Now this is what is a little bit technically different, but to get rid of 64, we're going to subtract 64 from both sides. Alright, in doing so, we're going to get a new equation. We're going to get the A squared. The 64s will cancel. That's the point. And you're going to get 80 on the right side. So we get 80. Alright, now we've got a square. The only way to get rid of the square is to take the inverse operation. So the inverse of squaring is square rooting. So we're going to square root both sides of this equation. And the reason is we've got a square and a square root. They cancel each other. Okay, so that's the point. That gets us rid of the squared symbol. So we're going to get A equals the square root of 80. Alright, now a lot of people would say we're done here. It's not necessarily a bad answer. Some people would plug this into a calculator. So they would say, okay, well, A is, if we plug that into a calculator, we're going to get 8.94. Perfectly great answer, rounded to the nearest hundredth. However, there's a better answer that we could use. Now the better answer would take this 80 and we would break up 80 into smaller parts. So we're going to break up the 80. We're going to take the square root of 80. We're going to break it up. So it turns out that when you break up 80 using a factor tree, we're going to get a lot of factors. So I'm going to have to write small here. But it looks like we're going to get a 2, a 2, a 2, a 2, and a 5. Okay, so, and that makes sense. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. So it looks like it's making sense. Alright, now when we look underneath our radical, we could see that I've got a 4. We're going to take the square root of 4. We also have another 4. So we're going to take the square root of that 4 also. So when we do that, we take the square root of 4 is 2. We take the square root of another 4 is 2, but we can't take the square root of 5. The 5 is still underneath the square root sign. So 2 times 2 is 4, and that would be 4 radical 5. So now this would be the exact reduced answer. So I would say that the exact answer is 4 radical 5, where we reduce the radical. See, it turns out that this 80 can be reduced, and that's why I did this off to the side, to reduce it. Sure, square root of 80 is the exact answer, it's just not the reduced exact answer. Alright, so these are our two answers. We've got a reduced exact answer and a decimal approximation, depending on which type of answer we're looking for. But this is how we use the Pythagorean theorem to take a hypotenuse in leg and solve it for the other leg. Make sure you go back to MATHguide.com, check out our other videos, our interactive quizzes, and activities. Take care.